Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine you're building an AI agent, not a chatbot, but a real autonomous system, one that receives events, keeps state, routes tasks, and doesn't collapse under load. Today, we are diving into OpenClaw Architecture Part 1, Control Plane, Sessions, and the Event Loop by Vinoth Govindarajan. This paper breaks down how OpenClaw structures the control plane of an agent system, the invisible layer that coordinates everything. Think of it as the nervous system of an AI agent, not flashy, but absolutely critical. So, what's the real problem here? Most AI demos stop at inference. Prompt in, answer out, but production agents are different. They receive events, they maintain sessions, they coordinate multiple components. Without structure, you get race conditions, lost state, duplicate execution. OpenClaw solves this by separating concerns into a structured control plane, gateway, session manager, event loop, queues. Instead of one giant loop, it's modular, composable, observable. It's less call the model and more orchestrated distributed system. Let's start with the gateway. Every request enters through it. It validates, authenticates, and normalizes input. Important detail: the gateway doesn't execute agent logic. It only translates external input into internal events. That's a clean boundary. Then comes the session manager. This is where things get interesting. Each user interaction belongs to a session. Sessions persist state across events. Think of it like a long running conversation object, but more structured, more explicit. Instead of relying on memory hacks, OpenClaw treats session as a first class architectural concept. That means deterministic recovery, replay capability, and horizontal scaling without losing context. Now, the heart of it all, the event loop. This isn't just a Python while loop. It's an event driven processing model. Events are queued, processed sequentially per session, but scalable across sessions. That distinction is powerful. Within one session, execution is deterministic. Across sessions, the system scales horizontally. It's basically controlled concurrency. And here's the subtle brilliance. Events, not function calls, are the primitive. This makes retries safer, failures isolated, observability easier. You're no longer debugging nested function calls, you are tracing event flows. Let's zoom into queues. Queues decouple producers from consumers. Input arrives, it becomes an event. The event gets enqueued, the loop consumes it. This separation prevents cascading failures. If model inference slows down, the gateway doesn't collapse. If a tool call fails, the entire agent doesn't freeze. Queues are the shock absorbers of this system. Another key idea from the paper: control plane versus execution plane. The control plane coordinates, the execution plane performs tasks like model inference or tool calls. This separation makes reasoning about the system easier. You can scale execution workers independently. You can evolve orchestration logic without touching inference workers. It's the same philosophy you see in container orchestration systems, but applied to AI agents. Now let's talk pitfalls. First, session state explosion. If you don't expire or compact sessions, memory will quietly become your bottleneck. Second, event ordering assumptions. Distributed queues can betray you if ordering isn't scoped correctly per session. Practical tip: treat events as immutable, log everything, and design replay as a first class feature, not a debugging afterthought. So, what does this paper really give us? Not just diagrams, not just architecture blocks, it gives a mental model. AI agents aren't prompt wrappers, they're distributed systems with state, with coordination, with control loops. OpenClaw's control plane shows how to structure that complexity without drowning in it. And this is only part one. Next time, we'll dive deeper into how execution flows through the rest of the stack. Because once you understand the control plane, you start designing agents differently. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.